Welcome to A-Level and EP Physics. In today's lesson, we will discuss important past paper questions on mechanics from May June 2022, paper 1, variant 1. In this video, we will discuss important concepts about mechanics by solving past paper questions. Let's study together, let's improve together. In today's class, we are talking about paper 1, variant 1 from May June 2022, and total time for this exam is 1 hour and 15 minutes, and total mark for this paper is 40. You should not use any correction fluid, and also you should not write on any barcodes. On second page of exam paper, you can also find values of some important constants, and maybe you will need some of them for some calculations in your exam. So if you need value of any constants, you can come back to second page and you can find value of constants. So this is very important point. You need to be clear that values of constants are given. So if you need, you can come to this page and you can find values of constants. On next page of exam paper, you can also find some important formulae, but these formulae are not all formulae you need for AS physics. So you need to be clear about this one. The first one, this is for uniform accelerated motion. You can only use this one if A is constant, means A is uniform. So this is very important point when you can use these equations. Only when A is uniform mean value of A is constant. Second one is about hydrostatic pressure. You can use this one, and in this formula, delta H is the depth. You can use this one and you can calculate value of P. Upthrust, this is new formula. This was not in 2021, but this is the new one in this list. So very important formula for upthrust. Next one is about Doppler effect for sound waves. This formula you can use when the source is approaching, or you can use this one when the source is moving away. But observer is at rest when the source is approaching. So simply I can write down when the source is approaching. If the source is approaching, you can use Fs over V minus Vs times speed of wave. So this one is the speed of wave. So in this case, observer has to be at rest. You can also use this one when the source is moving away. When the source is moving away, observed frequency will decrease. So we can calculate observed frequency by using same formula. Fs divided by V plus Vs times V. Actually, the better way of writing this formula is you can write down F observed. This is equal to speed of wave, means speed of sound, divided by speed of wave minus speed of source, and you have to multiply this one with frequency of source. So this is a proper way of writing this form, and this formula in the same way you can write down speed of wave divided by speed of wave, means sound, plus speed of source, and you need to multiply this one with frequency of source. So you can use this one when the source is approaching, and also you can use when the source is moving away. So this is when source is moving away, and this one when the source is approaching. And next one, this is about electric current. We also call this one transport equation. Very important formula. You need to understand how to use this one, transport equation. So this one is transport equation. And next two formulae for resistors in series, then also for resistors in parallel. These are basic formulae. You will need this one for some calculations in your exam. If you're not clear about any formulae, you can come to this page and you can check. For question number 1, we need to find out which term represents a physical quantity. Let's try to understand what is a physical quantity. When we can say a quantity is a physical quantity, a physical quantity can be measured. So the first property we can say a physical quantity can be measured. So we can call it a physical quantity if a quantity can be measured. But some quantities, for example, love, friendship, these are not physical quantities. You cannot measure them. And also physical quantity describe laws of physics. Or simply you can say it obeys laws of physics. Laws of physics. As I mentioned before, love, friendship, these are not physical quantities. They do not obey laws of physics. So these are not physical quantity like friendship, love, these things can be measured. It simply means that a physical quantity should have magnitude, must have magnitude, but it also can have unit. Unit is optional. Some physical quantities, they do not have unit. Like strain is a physical quantity, but it's a ratio between two physical quantities, so it has no unit. So a physical quantity must have magnitude and it should have unit most of the time. So we will use over this understanding of physical quantity and we will try to find out which quantity is a physical quantity. If you look at option A, this is not a physical quantity. This is just a unit. So this is not correct option. Percentage uncertainty is also not a physical quantity. Next one is quark flavor, means type of quarks like up quark, down quark. So this is also not a physical quantity. Spin constant is a physical quantity. It has magnitude and it also has unit. So this is our right option. I mean, this is correct option because spin constant has unit and also it has magnitude. K is equal to F over delta X and the unit of K is newtons per meter, and this one is a physical quantity. For the second question, we need to find out which two units are identical when expressed in terms of SI base units. So the best way to answer this problem is look at given options and try to write down which units are not SI base units. If you look at these given options, simply we can find out in this case joules is not SI base unit and Newton is also not SI base unit. But you need to be very clear that Newton and Joule, they are SI units, but they are not SI base units. So first of all, we can express Joule and Newtons into SI base units. First of all, Newton, simply we understand F is equal to MA, and SI base unit for mass is kilogram and for acceleration is meter per second per second. And for joules, we can simply understand joules means W is equal to FD, and for force we have SI base units, that is kg meter per second, and we need to multiply with m. So simply we can say SI base units for joules are kg meter square per second square. Now we can use these two and we can find our answer. If you look at first option, so this is joules per coulomb, option A. I will be writing here for A. For option A, we can write down kg meter square per second square per coulomb. So here we have per coulomb. And we also have in this case kg meter square per ampere per second square. Coulomb, actually this is also not SI base units. Coulomb we can also express C. This is coulomb, so Q is equal to IT, so we can say this is equal to ampere second. Q means coulomb is a unit of charge Q and Q is equal to IT. So C means this SI unit we can express in terms of SI base units. So we can replace C here now. We can rewrite kilogram meter square per second square, and this one is divided by ampere second. So we can say per ampere per second. So we can simplify this. We can write down kg meter square second cube, power of second is -3 and power of ampere is -1. Now if we compare these two quantities, if we compare this one with this, these two are not identical. It means option A is not correct. Now we can go to the second option, means we can write down for B. For option B, we have joules, so we can write down joules second. On other side, we can write down kg meter square per second. For joules, we understand joules is equal to kg meter square per second square multiplied by second. Now if we simplify, we will get kg meter square per second. Now if you look at these SI base units and on right side, these two are identical. So our answer for this one is B. So B is correct option. You can also check C and D, they will not be identical. So the answer for this one is B. You need to understand coulomb is also not SI base unit, but this is SI unit. So this is not SI base unit. Coulomb is not SI based unit, but ampere is SI based unit, so it is not SI based unit. For our third question, it is given to us a value for the acceleration of free fall on Earth is given as 10 plus minus 2 meters per second per second. For this question, we need to find out which statement is correct. If you look at given options, question is simply asking us about accuracy and precision. We need to find out, is this measurement, is it accurate or is it precise? So first of all, let's try to understand a little bit about accuracy and precision. Accuracy and precision. When we have understanding of these two terms, then simply we can find the answer. Accuracy simply means that how close calculated value is to actual value. How close calculated value, or we can say measured value, is to actual value. How close calculated value to actual value. So this is how we can define accuracy. Accuracy, this is how we can define. So this is how you can define accuracy. Precision simply means that how close measurements are to each other. Means you take measurements and how close they are to each other. That is the precision. If they are very close to each other, it means high precision. If they're not very close to each other, it means precision is low. How close measurements are to each other. How close measurements are to each other. So this is how we can state precision. Measurements are to each other. So this is how you can define precision. Let's try to understand this one with one simple example. Let's say we have actual value of G. Actual value of G is equal to 9.81 meters per second per second. We have two different measurements. Let's say in one measurement we got 9.70 and in another measurement we got 9.78. So we have two values of G. In this case, this one is more accurate because this is close to the actual value. So this is more accurate. But if you look at precision, let's say we have one set of data. We got 9.8 and we got 9. These are values of G. Simply you can imagine. We got 9.9 and we got 9.6. And we have another set of data and we got values 9, we got 10, we got 11. So in this case, this data is more precise because these measurements are close to each other. So this one is more precise. So simply we can write down this data is more precise, that this data is less precise because readings are not too close to each other. Less precise. In a simple way, we can say if data has more number of decimal places, it means that data is more precise as compared with data which has less number of decimal places. So simply we can say number of decimal places. If higher number of decimal places, it means data is more precise. Now if you look at 10 has range, so we can write down 10. It has range from 8 to 12, but our actual value is in this range. So this one is accurate. Mean this measurement is accurate because it is in this range. But this is not precise because it has no number of decimal places. If we compare this one with actual value of G, this value is more precise as compared with this value because this has no decimal places. So this measurement is accurate, but this is not precise. So the answer for this question is A, because this is not precise up to 2 dB, but our actual value is precise up to 2 dB. So the answer for this question is A, accurate but not precise. For question number 4, it is given to us two cables are attached to a bracket and exert forces as shown. We need to find out what are the magnitudes of the horizontal and vertical components of the resultant of two forces. So we need to find out horizontal component and vertical components of resultant force. So simply we can write down sum of horizontal components, or you can say sum of horizontal forces, and we need to find out sum of vertical components, mean along y-axis. For horizontal, if we resolve this force into two components, it has one horizontal component and it has one vertical vertical component. We can also resolve this one into two components, horizontal and vertical. So this force also has two components. First of all, we need to find the sum of horizontal components. So this horizontal component is equal to 15 cosine of 20 degrees. And this horizontal component is 6 times sine of 40 degrees, because this is opposite to angle, sine of 40 degrees. So simply we can write down here 15 cosine of 20 degrees. They are pointing in the same direction, so we have to add these two together. 6 sine of 40 degrees. So if we add these two together, sum of these two will be equal to 18.0 Newton. So this is horizontal component of resultant force, and direction of this one is to the right. Now we need to sum vertical component. So vertical component of this force is equal to 15 sine of 20 degrees. So if we take up is positive, so it means this component is positive. Simply we can write down 15 sine of 20 degree, and vertical component of this force is 6 cosine of 40 degrees. But this is pointing down, so this one is negative. We have 6 cosine of 40 degrees, and we can solve this one, and the magnitude of this one we will get, that one will be equal to 0.534. We are only concerned with magnitude. So this is the magnitude of vertical components. As magnitude of this component is positive, it simply means that direction of vertical component of resultant force is vertically upwards. So the answer for this question is C. Horizontal component is equal to 18.0 newtons and vertical component is equal to 0.534 newtons. So this is our answer. And this question is simply about resolving forces. You need to understand how to resolve forces into components. For question number 5, it is given to us the curved line PQR is the velocity time graph for a car starting from rest. We need to find out what is the average acceleration of the car over the first 5 seconds. In order to calculate average acceleration, we need to understand average acceleration simply is equal to total change in velocity over total time taken. In this case, total time taken is equal to 5 seconds. So if we have value of v at this point, we have the initial value of v that is equal to 0. So we can simply divide. We can find the difference and we can divide by total time taken and we can calculate average acceleration. And other way to calculate average acceleration is simply we can connect these 2 points by a straight line and we can find the gradient. I mean the total change in v divided by total time taken. So simply you can find the gradient of PQ. But you need to understand, if you calculate gradient of this curve at this point, you will get value of instantaneous acceleration. And if you calculate gradient at this point of the curve, you will get instantaneous acceleration at Q. You will not get average acceleration. So that's the reason answer for this question is C. Means the gradient of straight line PQ. Welcome to A-Level and AP Physics. In today's lesson, we will discuss some very important past paper questions on mechanics from June 2022, paper 1, variant 1. In this lesson, we will discuss some important concepts about mechanics by solving past paper questions. In order to get maximum benefit from this lesson, it is very important that you pause the video, do the question first of all by yourself, and then watch the solution. And this is the best way to get maximum benefit. Let's study together. Let's improve together. For question number 6, it is given to us a ball is thrown horizontally with a speed of 10 meters per second above horizontal ground. The ball hits the ground after a time of 3.0 seconds and a resistance is negligible in this case. we need to find out what is the speed of the ball just before it hits the ground. So the best way to answer this type of problems is, first of all, sketch. So in this case, we will imagine that the ball is thrown from this certain height, and it is given to us the ball is thrown horizontally, and the initial speed of this ball is equal to 10 meters per second. When we throw this ball, this will follow this path, and finally this will hit the ground. So this one is the ground, so it will hit this ground. Let me draw in a proper way so you can see the beautiful picture of that. It will hit the ground, so this horizontal line is simply representing ground. So this one is better one. So this is the ground. Now question is asking us, what is the speed of the ball at this point just before it hit the ground? So we need to find out the value of this speed. We can simply say this speed is speed, and this speed has two components, meaning this velocity has two components, and magnitude of this velocity is speed. So it has one horizontal component and one vertical component. We can say this one is Vx and this component is Vy. In this case, Vx is equal to initial horizontal speed because there is no air resistance. It means there is no force acting along horizontal, so the horizontal speed will not change. So horizontal component of velocity is equal to 10 meters per second. Now simply we need to find out the vertical component. If we can find out vertical component of velocity, we can calculate value of speed. In this case, speed will be equal to Vx square plus Vy square and root of this one. But in this case, we have value of horizontal component of velocity and we don't have value of vertical component of velocity. Now simply we need to calculate vertical component of velocity, and then we solve this one and we will get our final answer. So first of all, let's try to find out vertical component of velocity. To find vertical component, simply we need to consider vertical motion. Now, if we consider vertical motion, initial vertical velocity is equal to 0 because ball is just moving horizontally, just along horizontal. It has no initial velocity along vertical. So Uy is equal to 0. Time taken is given to us. So we have value of t that is equal to 3.0 seconds. We have value of a, and a is equal to 9.81 meters per second per second. In this case, acceleration is down, so we can also draw arrow here. Acceleration is down. We need to calculate value of v. Acceleration in this case is constant, uniform acceleration. So simply we can use v is equal to u plus at. In this case, we will take down is positive. So our answer will be positive. Means vertical component will be positive. So if we take down is positive, it means acceleration is positive. So we can write down u is equal to 0 and a is equal to 9.81 and time taken is equal to 3 seconds. So our final answer will be equal to 29.43 meters per second. And this is value of vertical component of velocity. Mean this value is equal to 29.43 meters per second. So this is value of Vy. Now simply we can plug in this value here. We have 29.43 square, and now if we solve this one, our final answer will be equal to 31 meters per second, and this is magnitude of velocity. Simply this is equal to speed of the ball when the ball hits ground at this point. So our answer for this question is C. C is our final answer. For question number 7, it is given to us an object is moving along the ground in a straight line at a constant speed. Body is moving in a straight line at a constant speed. It means that velocity of the body is constant. So we can simply sketch this one. Imagine that this one is the object, this is small car, and this is moving on the ground and its speed is constant. So it simply means that its velocity is also constant because it is moving in one direction and its speed is constant. So as in this case, delta v is equal to 0 means the change in velocity is 0. It simply means that a is also equal to 0 because a is equal to change in velocity over time taken. So this is also equal to 0. As A is equal to 0, it also means that resultant force acting on the object is also 0. So simply in this case, we will get F is equal to 0 because A is equal to 0. So the resultant force acting on the object is 0. Now, if you look at given options, for option A, it is given to us the resultant force acting on the object is equal to its weight. This is absolutely wrong because weight is acting vertically downwards. There will be reaction force, and this trolley is not moving up and down. So it means this one is totally wrong. So this is not correct answer. So this option is wrong. If you look at this part B, the resultant force acting on the object is equal to the product of its mass and its velocity. This is also wrong because this is statement of momentum, means momentum is equal to mv. So this is also not correct option. If you look at statement C, the resultant force acting on the object is equal to the resistive force. If there is a resultant force, it means body will have acceleration. So this statement is also not right. If you look at option D, the resultant force acting on the object is equal to 0. So this statement is correct, and this is our final answer. For question number 8, it is given to us water flows out of a pipe and hits a wall. When the jet of water hits the wall, it has horizontal velocity v and cross-sectional area capital A. The density of water is rho. The water does not rebound from the wall. It simply means that water just fall down vertically downwards like this. So this is how water will fall down vertically downwards. We need to find out what is the force exerted on the wall by the water. In order to answer this question, we need to understand the force on the wall and force on the water. They are action and reaction forces. So simply we can say force on water by wall will be equal to force on wall by water. These are action and reaction forces. We will add negative sign here. Means forces are equal in magnitude but opposite in direction. So forces are vector, so we can also add arrow here. Now we need to find out force on water by wall. If we have force on water by wall, we can find out force on wall by water. So this is force on water by walls. We will find out this force first of all, and this force is simply equal to change in momentum of water, means is equal to rate of change of momentum of water, and rate of change of momentum is equal to m times delta v over delta t. We can rearrange this one. We can write down this is m over delta t, mean this is mass flow rate time change in velocity. In this case, we will take to the left positive. To the left is positive. If we take to the left is positive, so it means v will be negative. So we can write down m over delta t. This is the mass flow rate, and the change in velocity is 0, means the final velocity along horizontal is 0. 0 minus v, and the v in this case is negative. So v is negative because v is to the right and we are taking to the left as positive. So simply now we can write down this is equal to m over delta t times v. Now we need to write down mass flow rate, and mass flow rate simply equal to density of water times cross-sectional area times speed of water. So this is one v speed of water, and the other v we already have here. So this is another v. Now we just need to simplify this. In this case, we have density, we have area, cross-sectional area, and v multiplied with v. So this is v squared. So in this case, force on water by wall. So the force on water by wall, this is equal to rho a v squared, and this is also equal to force on wall by water. So we can write down the force on water by wall. This is equal to rho a V square. So we can write down force on wall by water. Force on wall by water. This is equal to negative of this. Means the force on wall by water is to the right. We have got negative answer. So it means force on the wall by water is to the right. So this is how we can answer this question. For this question, simply we need to write down magnitude. So the answer is this one. So let me explain you a little bit about mass flow rate. So m over delta T. This is mass flow rate. This is how we represent this one. Mass flow rate means that mass over time, and the mass is equal to density times volume. Mass is equal to density times volume divided by time. So divided by T. So in this case, we can write down density, and the volume is equal to A times. So volume is A times L over T. So L over T in this case is equal to V. So the mass flow rate is equal to rho A V, and this V is the speed. So this is what we have written here. So the mass flow rate is equal to density times cross-sectional area times speed. So this is how you can write down mass flow rate. This is the point you need to understand to answer this question, mass flow rate. So in this case, our answer is T. But you can also find the answer of this question by just matching unit. Unit of force is Newton, and in SI base unit we can write down this is equal to kg meters per second per second. Now if you look at the units of this, you can see this is kg per cubic meter, means this is the unit of density, and unit of cross-sectional area is meter square, and unit of V square is equal to meter square per second square. Now if we simplify this, so you will get in this case we have kg meter per second square. So it means this is the right option. This is correct answer. So you have two different approaches. Unit matching is also very important skill in physics. You can use this method, you can use the method I have just explained to you using concept of rate of change of momentum. So you can use any method, and both of these methods are very important. Mass flow rate concept is very important, and unit matching is also very important. You need to understand both of these methods. So these two methods are very important. You need to understand both of them to answer questions with confidence. For question number 9, it is given to us a projectile is launched at an angle above horizontal ground and travels through air. The projectile reaches its maximum height at position X. Assume that no upthrust acts on the projectile. Which diagram shows directions of the force or forces acting on the projectile at position X? So we need to find out direction of force or direction of forces acting at point X. In this case, projectile is moving through air. It simply means that we cannot ignore air resistance. Now we need to understand what is direction of motion of projectile at point X. At point X, projectile will be moving to the right. So this is the speed of projectile. Our projectile is moving to the right. As projectile is moving to the right, now we need to imagine air resistance. So imagine that there are air particles. So we cannot ignore air resistance in this case. So you can imagine there are air particles. Simply you can imagine like this. Now if the ball is moving to the right, it will hit particles to the right, and air particles will hit this ball to the left. So it simply means that there will be air resistance to the left. So we have one force that is acting to the left. We can draw forces here. So this is force due to air resistance that is acting on projectile to the left. So this is air resistance. And also there is gravity acting on this ball that is acting vertically downwards. So this is weight. So simply our answer for this question is B. Very nice question. You need to understand in this case you cannot ignore air resistance because it is falling through air. So the answer for this question is B. For question number 10, we need to find out what is the statement of the principle of conservation of momentum. Principle of conservation of momentum simply tells us that in any collision, so let's try to understand first of all what is principle of conservation of momentum. In any collisions, change in momentum is equal to 0. Means momentum is conserved if no net external force is acting on the system. No net external force is acting on the system. No net external force acting on the system, then momentum in any collision is conserved. Acting on the system we define, acting on the system, then momentum is always conserved. So this is how we can state, or simply we can say, in an isolated system, isolated system also means that there is no external forces acting on the system. In that case, momentum is also conserved. So we need to find out which statement is correct. If you look at statement A, it's telling us a force is equal to the rate of change of momentum. This is not statement of conservation of momentum. So this is just statement of resultant force. So this is not true. For option B, it is given to us, in a perfectly elastic collision, the relative momentum of the objects before impact is equal to relative momentum after impact. This is true, but this is not only true for perfectly elastic collision. This is true for any type of collision if there is no net external force acting on the system. So this is also not correct option. If you go to option C, it is given to us, the momentum of an object is the product of the mass of object and its velocity. This is true for momentum, but this is not statement of conservation of momentum. So this option is also not correct. For option D, it is given to us, the total momentum of a system of interacting objects remains constant, providing no resultant external force acts on the system. And this statement is true for conservation of momentum. So our answer for this question is D. For conservation of momentum, you need to understand momentum is only conserved if there is no net external force acting on the system. Momentum is still conserved if there are internal forces. Momentum is still conserved means when something explodes, there are internal forces. But momentum is still conserved. Momentum is not conserved if there are external forces acting on the system, means net external forces acting on the system. In that case, momentum is not conserved. So very important point you need to understand when momentum is conserved and when momentum is not conserved.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss important past paper questions on mechanics and fluids from May June 2022, Paper 1, Variant 1. In this lesson, we will talk about mechanics and fluids. We will try to understand these two topics by solving past paper questions. Let's study together. Let's improve together. For question number 11, it is given to us, a horizontal wooden plank is pivoted at one end as shown in this figure. The plank has a mass of 100 kilograms and a length of 10 meters. The center of gravity of the plank is a distance of 4 meters from the pivot. We need to find out what is moment of the weight of the plank about the pivot. So question is very straightforward one. Simply you need to find out moment of the weight about the pivot. Now we need to find out where the weight is acting. As the center of gravity is at 4 meters, it means weight is simply acting at this point. And the mass of the plank is given, that is equal to 100 kilogram. So the weight will be equal to 100 kilograms multiplied by 9.81. So this one is the force. We need to calculate moment. Moment, we can use symbol capital M for the moment, and moment is equal to force time perpendicular distance from the pivot. In this case, force is equal to 100 kg times 9.81, and the distance from the pivot is 4 meters. So our final answer in this case will be close to 4,000. It will be very close to 4,000. So simply in this case, we can write down our final answer. This is equal to about 4,000 Newton meter. We can also write down this one in standard form. So we have 4.0 times 10 to 3 Newton meter. So the answer for this question is C. So this one is the right answer. For question number 12, we need to find out when must an object be in equilibrium? Is a typical type of question. They will ask you this question in different ways. Simply you need to understand when an object can be in equilibrium. Means what are the basic conditions for an object to be in equilibrium. The first condition is that sum of the forces acting on the object has to be equal to 0. Now simply we can say resultant force has to be equal to 0 in any direction. It means upward forces has to be equal to downward forces and left side has to be equal to right side. Means the forces acting along horizontal to the left has to be equal to the forces acting along horizontal to the right. In any direction, sum of the forces has to be equal to 0. So this is one condition. And the second condition is that net torque has to be equal to 0. Net torque has to be equal to 0. Simply you can say clockwise moment has to be equal to anti-clockwise moment about any point. So about any point. It simply means that for an object to be in equilibrium, object has to satisfy these two basic conditions. Now let's look at options and try to find out the best possible answer. If you look at option A, it is given to us no resultant force acts on the object. If no resultant force is acting on the object, it simply means that acceleration of the object will be equal to 0. And this is one of the conditions for equilibrium. So this is not best possible answer. Now if we go to option B, it is given to us no resultant force and no resultant torque act on the object. And this is the best possible answer because it satisfied these two conditions. So the answer for this question is B. Now if we go to option C, no resultant torque, this is one of the conditions. So this is also not best possible answer. If we go to part D, means option D, it is given to us when the upward force on the object is equal and opposite to its weight. It simply means that resultant force is equal to 0, and this is one condition for equilibrium. So this is also not answer for this question. So the answer for this question is B. So object has to satisfy these two conditions to be in equilibrium. For question number 13, it is given to us a uniform diving board is held by two fixed rods at points P and Q. A person stands at end R of the diving board as shown in this figure. The forces exerted by the rods on the board are vertical. The board remains in equilibrium as the person slowly moves towards point Q from end R. Means when the person is moving this way, this diving board, it remains in equilibrium. So this is the main point you need to understand from here. And we need to find out which row describes the changes to the magnitude of the forces exerted by the rods on the board. Means the change in forces exerted by rod Q and by rod P. This question is about equilibrium. Now we need to understand, we can take one point as our pivot point because diving board is in equilibrium. It means that moment about any point has to be equal to 0. So in this case we will take moment about rod Q. So this one is our pivot point. So simply we can say this one is pivot. As this diving board remains in equilibrium, so it means that the moment about this pivot has to be equal to 0. And the force acting at pivot, let's say this force is FQ. And FQ has to be equal to the force exerted by this rod. This force is down. We can simply say this force is FP. And let's say the weight of this person is W. P has to be down because the moment, if you take moment about this point, moment due to weight, it is clockwise, and moment due to force exerted by rod P, this one has to be anti-clockwise, and that is only possible when the force by this rod is downwards. It has to be downwards. You can simply imagine this is my finger, so this is the rod and this is the diving board. Simply you can understand this one is diving board and the rod is placed here, so rod is at the top. So when the person is walking this way, person will try to produce clockwise movement. So it will push this rod up. So the rod will push diving board down. So the force by the rod on diving board, it has to be down, because due to moment of the weight, there will be clockwise movement, means it will try to rotate clockwise. So this diving board will try to go up on the left side. So the rod will push this one down, means the diving board push rod up and the rod will push diving board down. So the force by the rod on diving board, it has to be down. So that's the reason force at P has to be down, means the force by the rod on diving board, it has to be acting downwards. And in this case we can also say that FQ, this has to be equal to FP, and it has to be equal to weight of the person. So this is one equation we can write down. And second, we need to understand about moment. If we take the moment of this person, let's say weight of this person is W, and imagine that the distance of this person from the pivot, we can say the distance is dW. Distance is dW, and let's say the distance of this force P from the pivot, let's say distance is dP. So the moment due to the person has to be equal to moment due to the rod at point P. So we can write down FP, force P, time distance of the force from the pivot, it has to be equal to weight of the person time distance of the person from the pivot. In this case, distance of rod P from the pivot is fixed, so this distance is fixed, and W is also fixed in this case, because weight of the person is not changing when the person is moving to the left, means when person is getting closer to the pivot, so the weight is fixed. But you need to understand, when the person is moving to the left, mean is getting close to the pivot, it means dW is decreasing. As dW is decreasing, so FP also has to decrease. So in this case, FP will decrease. So the force at P has to decrease. Now if you look at forces acting at Q, in this case W is fixed, but FP is decreasing. So it simply means that force at Q also will decrease. So FP will decrease and FQ will also decrease. So the answer for this question has to be A, and this is the best possible answer. For this question, simply you need to understand equilibrium. Two conditions for equilibrium. Clockwise moment has to be equal to anti-clockwise moment, and sum of the forces in any direction has to be equal to 0. So you have to use these two conditions to answer this problem, and this is how you can answer this problem. And this is very nice question on equilibrium. For question number 14, it is given to us a solid block has sides of length L, 2L and 4L. The block is submerged in water of uniform density so that the faces with the largest area are horizontal as shown in this figure. The upthrust acting on the block is U. The block is now rotated to a new position so that the faces with the smallest area are horizontal. The block remains fully submerged in the water. We need to find out what is the upthrust acting on the block in its new position. So first of all, we need to understand what is upthrust. Upthrust simply is equal to weight of fluid displaced. So simply we can say upthrust is equal to weight of fluid displaced. Weight of fluid displaced. It simply means that when you submerge object in a water or in any fluid, the amount of water displaced by the object. If you measure the weight of that, the force on the object will be equal to the weight of that amount of fluid displaced by object. So very simple concept. Upthrust is equal to weight of fluid displaced. Mean how much fluid is displaced by the object. If you measure the weight of that weight is equal to the force acting on the object in upward direction. So simply we can say upthrust is equal to mass of the fluid displaced times g. We can also write down mass of the fluid displaced. This is equal to density of the fluid. Density of fluid times volume of fluid displaced times g. So this is how we can find out upthrust. Now let's try to answer this question now. For this question, it is given to us when we rotate this one. This is horizontal first of all. So simply you can imagine that this one is our box. It is placed horizontally inside water, and then we rotate this one like this, but it is still in water now. As long as it is in the water, it doesn't matter how this is placed inside the fluid, upthrust will be the same, because the weight of fluid displaced will be the same, or simply we can say the amount of fluid displaced will be the same. So the volume of fluid displaced same, density of the fluid is the same, so the force acting on the object also will be the same. So upthrust in this case will be the same. So again, let me explain to you. First of all, object was placed inside the fluid like this, and then we rotate this one like this, but it is still inside the fluid. So the upthrust in this case will be the same, and upthrust still equal to capital U. So the answer for this question has to be B. For question number 15, it is given to us in a large container in an oil refinery, 3 oils of different densities are mixed. No chemical activity occurs. The mixture consists of 1200 kilograms of oil of density 1100 kilograms per cubic meter, 1500 kilograms of oil of density 860 kgs per cubic meter, 4000 kilograms of oil of density 910 kilograms per cubic meter. We need to find out density of the mixture. Pretty straightforward question if you have clear understanding of this. Otherwise, it can be very confusing for some students. We need to find out density of mixture. So simply I will write down here first of all density of mixture. So we need to find out density of mixture. And density of the mixture will be equal to the mass of the mixture. So we can say capital M, mass of the mixture, divided by volume of mixture. So we can write down volume of mixture. We need to find out mass of the mixture, and mass of the mixture is equal to this total mass. So we can write down the total mass is 1200 kilograms plus 1500 kilograms plus we have 4000 kilograms. So this is the total mass of the mixture. Now we need to find out volume of the mixture, and volume of the mixture is equal to the volume of these 3 different oils. For first oil, we can say, let's say V1, the volume of first oil. We can take the mass of the oil, we can divide this one by density of the oil, and in this case our answer will be equal to 1.09 cubic meter. So this is the volume of oil 1. We can also calculate volume of second oil. We have the mass of the second oil, so this is mass divided by density. Density is equal to 860. So in this case our answer will be equal to 1.74. So 1.74 cubic meter. We can also find out the volume of third oil. Let's say this is V3. So this one will be equal to given mass of the oil divided by density of the oil. If we solve this one, in this case our answer will be equal to 4.4 cubic meters. Now we have the total volume of mixture. So it simply means that we have to add all of them. If we add all these volumes, we can find volume of the mixture. So volume of the mixture is simply equal to 1.09 plus 1.74 plus 4.4. And if we solve this one, our final answer in this case will be equal to 927 kgs per cubic meter. So this is density of mixture, and our answer for this question will be A. So A is the best answer. So simply you need to understand how density of the mixture is linked with volume of the mixture and mass of the mixture, means total mass of the mixture. Masses are given to us, so we have these masses, simply we need to add them. That will be equal to the total mass of the mixture. Densities are given for each oil and the mass is given. We can find out volume of each oil, and if we add all volumes of oils together, we can find out the volume of the mixture. Then total mass divided by total volume, we can find out density of mixture. This is the best way to approach these problems. So when you see this kind of problem, no need to get frustrated. Just try to understand what is given to you and what you need to find. You will be able to answer if you have understanding of this question. I hope this question is clear to you, and if you have any questions, please leave your questions in comments and I will answer as soon as possible. Welcome to A-Level and AP Physics. In today's lesson, we will discuss some important past paper questions on mechanics from May June 2022, paper 1, variant 1. In this lesson, we will talk about mechanics concepts by solving past paper questions. Let's study together, let's improve together. For question number 16, it is given to us a box slides down a rough ramp. The change in gravitational potential energy of the box is 16 joules as it moves between positions X and Y. The box has 24 joules of kinetic energy at X and 35 joules of kinetic energy at Y. We need to calculate how much work is done against the frictional force. So first of all, we need to understand this question is about conservation of energy. Now we need to understand how to apply conservation of energy. For this question, it is given to us that change in GPE, so simply first of all you can write down change in GPE between X and Y is equal to 16 joules, and we have value of kinetic energy at point X that is equal to 24 joules, and kinetic energy at point Y is also given. So Ke at Y is given, that is equal to 35 joules of energy. We need to calculate work done against frictional forces. Now we need to understand gravitational potential energy. It depends on reference point, or simply you can say the reference level, or we can say it depends on the reference line. So let's say this is our reference line, and at this point H is equal to 0. If we take height at Y is equal to 0, it simply means that GPE at point Y is equal to 0. So it simply means that GPE at point X, we can write down GPE at point X, this one is equal to 16 joules. And we have value of kinetic energy at point X, that is equal to 24 joules. So we can also write down Ke at X, this one is equal to 24 joules. We have value of Ke at Y, we can write down at this point Ke at Y, this one is equal to 35 joules. And now simply we need to apply law of conservation of energy, mean principle of conservation of energy. So the energy total at point X has to be equal to total energy at point Y. At point X we have Ekx, so we can say kinetic energy, so this is Ekx plus we have GPE at point X. This one has to be equal to kinetic energy. So this is symbol for kinetic energy at point Y. This is also kinetic energy plus GPE at point Y. GPE at point Y plus work done against frictional forces. Now simply we need to plug in values. First of all, we can rearrange this one. We can write down WF. This is what we need to calculate. This is work done against frictional forces. This one has to be equal to kinetic energy at X. I'm using KEX, EKX, KEX, they are the same, plus we have GPE at X minus KE at Y minus GPE at Y. So the best way, first of all, rearrange, then plug in numbers. KE at X we have that is equal to 24 joules, and we have GPE at X that is equal to 16, and we have value of KE at Y that is equal to 35, and we have GPE at Y that is equal to 0 because this is at the reference line. This one is equal to 0. Now simply we solve this one for WF, mean work done against friction force. Our final answer in this case will be equal to 40. 24 plus 16, 40 minus 35. So the final answer is equal to 5 joules. So the answer for this question is A. So you need to understand for this question how to apply principle of conservation of energy. And this is how you can apply. Total energy at point X has to be equal to total energy at point Y, and this is how you can apply. For question number 17, it is given to us the total energy supplied to an electric motor is capital E. Energy Q is wasted and the remaining energy does useful work. We need to calculate efficiency of the motor. First of all, let's sketch this one. Imagine that this one is the motor, so we will use letter capital M for motor. Input energy for this motor is given, that is equal to capital E. So this one is the input. Wasted energy is given. Q is the wasted energy, and useful energy we can calculate from here. So the useful energy in this case will be equal to E minus Q. So this one is useful and this one is wasted. So simply we can write down this much energy is wasted and this much energy does useful work. So we can simply write down useful and this one is input. We need to calculate efficiency for this. Efficiency is equal to useful energy output, useful E out divided by total input energy. So simply we can write down total input energy. In this case, useful energy output is equal to E minus Q, and total energy supplied is equal to capital E. So if we simplify this one, we can write down this is equal to 1 minus Q over E, because E will be cancelled. Let me write down one step more here. So this is E divided by E. If we simplify this one, we will get 1 minus Q over E. So this is efficiency. So this is how you can calculate. Simply you need to understand useful energy output divided by total input energy, that is equal to efficiency. If they ask you to calculate percentage, so you will multiply by 100. So here we will use sign for percentage, and here we will multiply by 100 if you need to calculate percentage efficiency. For this question, simply we need to calculate efficiency, so we no need to multiply by 100. So the answer for this question is C. So C is the best possible option. For question number 18, it is given to us objects with different masses are placed on a horizontal surface of a table. The objects are raised to different heights above the table. The gain in gravitational potential energy of each mass is the same. Which graph best shows the variation of the height h of the objects above the table with their mass m? So in this case, it is given to us, we have a table, and on this table we place different masses. So masses are different and we raise them to different heights. but they have the same gravitational potential energy. Imagine that we have one mass, so this one, let's say this mass is capital M, and we have another mass, let's say this is small m. We raise this mass to this height, we raise this one to this height. So in this case, the height of this one, imagine that this one is capital H, and we raise this one to higher height. So these two masses, they have the same change in potential energy, means they have the same gravitational potential energy with respect to this table. Let's say this height is H. So in this case, you can see if we write on the formula for gravitational potential energy, GPE delta GPE, this is equal to mg delta H. So if m is small, for the same GPE, simply you can understand from here, if m is small, g is constant, so delta H has to be higher, and vice versa is also true. We can also write down delta GPE, this is equal to capital M G, and we can write down capital delta H. So if m is big, so delta H has to be small, because GPE, the change in GPE is the same. So it simply means that when m is increasing, it means height has to decrease, and that is only true for A. Or simply you can say m and delta H, they are inversely proportional. Let's try to write down this equation in a little bit different way so you can have clear understanding of this. In this case, simply we can write down delta GPE, this one is equal to mg delta H. Now we can place delta H on one side, and we can write down that delta GPE divided by mg, this is equal to delta H. We can again rewrite this. In this case, GPE, change in GP over G is constant, so we can write down delta GPE over G, this is constant, and this is multiplied by 1 over m. Now in this case, you can see delta H and m, they are inversely proportional, so that's the reason shape of the graph, we can also write down here delta H in this case is inversely proportional to m. So the shape of the graph has to be hyperbola. So that's the reason our answer for this question is A. For question number 19, it is given to us two wires P and Q are made from the same metal and hang vertically from a steel girder. Wire Q has half the length and twice the diameter of wire P. Identical masses are attached to the bottom of each wire. Both wires obey Hooke's law as they are stretched by the weight of the masses. We need to find out the ratio between extension of wire P and extension of wire Q. So this is a typical type of question about Young's modulus. First of all, let's try to understand what is happening in this case. So simply you can imagine that we have a support, or you can imagine that this is a girder and wire P is attached with this one, and certain weight is hanging with this. Let's say the mass of the weight is capital M, and we can say this is wire P. And we have also another wire, that is wire Q, and this is made of the same material, and this wire has half the length. So you can also draw like this. So this is half the length, meaning it's shorter than P. So this one is wire Q, and the same mass is hanging at the bottom of this wire. We need to find out the ratio between extension of wire P and extension of wire Q. In order to answer this question, we need to use Young's modulus. So we can write down Young's modulus. This is equal to stress over strain, means we can write down F over A, this is stress, divided by delta L by L. If we rearrange this one, we can write down FL over A times delta L. So this is Young's modulus. Now in this case, we need to understand what is same for P and what is same for Q. We can write down here, we have wire P and we have wire Q. Both wires, they are made of the same material. It means E is the same. and there is the same weight is hanging at the bottom of each wire, so it means F is also the same. So the force is also the same. So these two quantities are same. Now imagine that wire Q, the length of this one, let's say, is L. If the length of Q is L, so the length of P has to be 2L, because it is given to us that wire Q has half the length. So we have assumed if wire Q, for example, this is the length of this one is L, so the length of P has to be equal to 2L. It is also given to us Q has twice the diameter. Now we need to understand the relationship between diameter and cross-sectional area. Area is equal to cross-sectional area is equal to pi by 4 d square. If diameter is double, it means cross-sectional area will be 4 times. Now we can assume, let's say, cross-sectional area of P is A. So the cross-sectional area of Q, this one will be equal to 4A. So these are the information we need to understand about wire P and wire Q. Now simply we can use over this understanding and we can answer this question. You can see here, if we rearrange this one, we can write down E over F. This one will be equal to L over A times delta L. But E over F is the same for P and also same for Q. So it means this one is equal to constant. We can also write down here. So L over A times delta L is equal to constant. So we can write down LP over AP times delta LP. This one has to be equal to LQ divided by AQ times delta LQ. We can cross multiply, means like this. If you cross multiply, we will get here LP, and this is AQ, and we will have delta LQ. This one will be equal to LQ times AP times delta LP. We need to find out the ratio between delta LP and delta LQ. So we can divide this side. We can divide this side first of all by delta LQ. So we will get delta LP, mean this one, divided by delta LQ. And this one has to be equal to LP AQ divided by LQ times AP. Now we can plug in values. LP, this is equal to 2L, so we can replace this one with 2L. And AQ, this is equal to 4A, so we can replace this one with 4A. We can divide this by LQ. LQ is equal to L, so this is L. And AP, this one is equal to A. This one was equal to 4A. So we have in this case AQ that is equal to AP, that this is AP, so AP is equal to A. Now simply just cancel. L will be cancelled with L, A will be cancelled with A. So we left with 8 by 1. So the answer for this question is A. So this is the answer. This is the best technique to handle Young's modulus questions or any other where you have to compare two different wires, you have to compare two different resistors. You can use the same technique. Very useful and powerful technique to answer this kind of questions. When there is a comparison between two wires, comparison between two resistors, you can use this technique. I hope this is clear to you. If you have any question, just leave in comments. So the answer for this question is A. For question number 20, we need to find out which statement about elastic and plastic deformation must be correct. First of all, let's try to understand what is elastic deformation and what is plastic. Elastic deformation simply means that if we deform any object elastically and we remove the force, object can regain shape. So simply we can say elastic deformation means that when the external force is removed, object can regain shape. So we will write down object can regain shape if object has been deformed elastically. Plastic deformation means that if an object has been deformed plastically, object will not be able to regain shape. We will simply say cannot regain shape. Mean if object has been deformed plastically, object cannot regain shape. So this is the difference between elastic and plastic deformation. Let me explain you this one with one simple example. Look at my cheek and finger. If I place finger on my cheek and I press this one, you will see the dimple. And if I remove the force, it will regain shape. So this is example of elastic deformation. Means my cheek was deformed elastically, and when I remove the force, it regained shape. So this is elastic deformation. And plastic deformation means that when you apply force on something, let's say if someone hit my face and there is a dent on my face, so my face has been deformed plastically. So that is an example of plastic deformation. So this is how you can understand elastic and plastic deformation. So let me show you this one with this one simple example as well. Now if I apply force on this, you will see here. So I apply force. Now if I remove the force, it doesn't come back to the same shape. So it means this has been deformed, this wrapper has been deformed plastically. So this is an example of plastic deformation. So if I apply force, then I remove the force, you will see it will not regain shape. So this is an example of plastic deformation. So now we need to find out our answer for this question. For option A, it is given to us elastic deformation and plastic deformation are proportional to the applied force. This is not true. This is incorrect. Elastic deformation and plastic deformation cause no change in volume. This is also wrong. They cause change in volume. Plastic deformation, this causes change in volume. So this is also incorrect. Elastic deformation causes heating of the material, but plastic does not. This is also not compulsory. So this one is also wrong. Elastic deformation is reversible, mean it can regain shape, but plastic is not. This one is true. So the best option for this question is D. So D is the answer. Welcome to A-Level and UP Physics. In today's lesson, we will discuss some important past paper questions on waves from May-June 2022, Paper 1, Variant 1. In this lesson, we will discuss these questions in detail so you can have clear understanding of these questions and also you can improve your conceptual understanding of this topic. Let's study together. Let's improve together. For question number 21, it is given to us the graph shows the variation with time of the displacement of a particle as a progressive wave passes. We need to find out what are the frequency and amplitude of the wave. This question is pretty straightforward one. In this case, you can see on y-axis we have displacement. So it means the maximum displacement that is equal to amplitude. Maximum displacement is equal to amplitude. So simply we can write down here amplitude is maximum displacement. Amplitude is equal to maximum displacement. So the amplitude is equal to 5 millimeters. Now we need to find out frequency, but we can find out time period from here. Time taken to complete one cycle, or we can say time taken for one wave to pass through a point. That time taken is one time period. So in this case, this is one time period. So in this case, t is equal to 10 nanoseconds. So simply we can say 10 times 10 to negative 9 seconds. Simply we can say this is 10 to negative 8 seconds. We need to find frequency. So simply we can write down frequency is equal to 1 over time period. So we can write down 1 over 10 to negative 8. So it simply means that this is 10 to 8 hertz. Or we can write down this is 100 times 10 to 6 hertz, and 10 to 6 is equal to mega. So it simply means that frequency is equal to 100 megahertz. So the answer for this question is A. So pretty straightforward question. You need to understand what is amplitude and what is frequency, and how to read from displacement time graph. So pretty straightforward one. So the answer for this question is A. For question number 22, it is given to us the graph shows the variation of the displacement of an air particle with time as a sound wave passes through air. The intensity of the sound is halved and the frequency remains constant. The four graphs below are drawn to the same scale as the graph above. Which graph shows the displacement of the air particle? Let's assume that initial intensity I1 is equal to I0 and initial amplitude A1 is equal to A0. But A0 we can read from here. In this case, you can see the initial amplitude of the wave is equal to 4 boxes. So simply we can write down this is equal to 4 small boxes. We can also assume the second intensity, or we can say the final intensity I0. I0 is equal to I0 by 2. So we can find out value of final amplitude. We also understand intensity is directly proportional to amplitude square. So we can simply say I1 over A1 square. This one will be equal to I2 over A2 square. In this case, we need to find out A2, so we can rearrange this one. We can write down A2 square, in this case will be equal to I2 times A1 square divided by I1. I2 is equal to I0 by 2 multiply by A1, and A1 is equal to 4 boxes. So we can say this is equal to 4 boxes square. Divided by, we have intensity 1, that is equal to I0. So we can simplify this one. So in this case we will get this is I0 divided by 2 times I0 multiply with 16. So we can cancel I0 with I0, and if we cancel 16 with 2 we will get 8, and this is A2 square. But we need to find out A2. So simply A2 is equal to root of 8, or simply we can say this one will be equal to 2.8. So the amplitude is equal to 2.8 boxes. And now we can check different waves and we can find the answer. In this case, frequency is the same, so time period is the same. So if you look at first one, in this case its amplitude is equal to 4 boxes, so this is not possible answer. If you look at this one, this has different time period, and this also has different time period, so this is not possible, this is also not possible. Because frequency remains same, it means time period also remains same. So A and B, they are not possible answers. But if you look at C, so in this case you can see the time period is equal to 4 boxes, and this time period is also equal to 4 boxes, so this can be the answer. But amplitude of this one is not equal to 2.8 boxes, so this is only equal to 2 boxes, so this answer is not possible. But if you look at this now, in this case the time period is equal to 4 boxes and amplitude of this one is equal to about 2.8 boxes, so this one is the best possible answer. So this is how you can approach this problem. Simply you need to understand intensity is directly proportional to amplitude square. Then as I is directly proportional to amplitude square, it means you can write down I is equal to K times A square. So the ratio between intensity and amplitude square, this is equal to constant, and this is true for both waves. So that's the reason we have written I1 over A1 square is equal to I2 over A2 square, and then we can simplify and we can find value of A2. So this approach is very common approach. You need to understand how to use this approach. For this question, we need to find out which statement is correct. For option A, it is given to us gases cannot transmit longitudinal waves. This one is incorrect because longitudinal waves are mechanical waves and they need medium to travel and they can pass through gases. So option A is incorrect. For option B, it is given to us longitudinal sound waves cannot form stationary waves. This option is also incorrect because sound waves, they can form stationary waves. As we see the waves in organ pipes, those waves are examples of stationary waves. So option B is incorrect. Solids can transmit both transverse and longitudinal waves. This is true because if transverse waves and longitudinal waves, they are mechanical waves, they need medium to travel, so they can pass through solids. So option C is correct. Option D, transverse waves cannot pass through a vacuum. As in case of electromagnetic waves, all electromagnetic waves, they are transverse waves and they can pass through vacuum and they do not need medium to travel. So the option D is incorrect. Electromagnetic waves, they can pass through vacuum. So D is also incorrect. So A is incorrect, B is incorrect, D is also incorrect. So the answer for this question is C. For question number 24, it is given to us a car is traveling at a constant velocity directly towards a man standing in the middle of the road. The driver sounds the car's horn as a warning. The horn emits a sound wave of constant frequency. The frequency of the sound heard by the man is different from the frequency of the sound emitted by the horn. We need to find out which statement is correct. First of all, let's try to sketch. Imagine that this is the car and this car is moving to the right with constant velocity, and this car produces sound with certain frequency fs, and there is a person who is standing right in front of the car. Let's say this observer is at rest, mean person is not moving. As this car is approaching, so in this case you need to understand car is approaching. It is given to us it is moving directly towards the person. So car is approaching observer. If the car is approaching observer, observed frequency of the sound by this person, observed frequency will be greater than frequency of the sound produced by a source. Now we also need to understand V means the speed of the wave in the medium. It will not change because medium is the same, type of wave is the same. So it means speed will remain constant. So speed remains constant and speed is equal to f times lambda. If f increase, it means lambda will decrease. So simply we can say in this case lambda observed, this will be smaller than lambda of the source, means lambda of wave produced by the source. Now we have understanding of these two things, mean how frequency will change and how lambda observed will change. So we can find the answer. The frequency of the sound emitted by the horn is greater. This one is wrong because this frequency will be lower. So this one is wrong. So option A is not correct answer. The frequency of the sound heard by the man depends on the distance. It does not depends on distance. It depends on speed of the wave and also it depends on speed of the source. So observed frequency, this depends on speed of the wave and it depends on speed of the source. When it is approaching, so you have to use minus sign. So speed of the source and it depends on frequency of the source. So B is also incorrect. The sound waves continually accelerate as they move from the horn to the man. Speed of the wave does not change. If type of wave is the same, medium is the same, speed of wave will not change. So C is also incorrect. The wavelength of the sound heard by the man is less than wavelength of the sound emitted by the horn. So this one is true. So the answer for this question is D. So D is correct answer. For question number 25, we need to find out which statement about electromagnetic waves is correct. For option A, it is given to us a wave of wavelength 5.0 times 10 to minus 6 meters is invisible to human eyes. In order to decide whether we can see this wavelength or not, we need to understand visible part of electromagnetic spectrum. Visible part of electromagnetic spectrum is visible to human eyes. Visible light, so simply we can say visible light means the light can be seen by human beings. The range of visible light is from 400 nanometer to 700 nanometers. We can convert this one into meters, so this will be equal to 4.0 times 10 to minus 7 meters, and this one will be equal to 7.0 times 10 to minus 7 meters. But now if we compare this one with the given wavelength, this has power 10 to minus 6. So this wavelength is longer than the visible part of electromagnetic spectrum. So we cannot see that. We can only see this range of wavelengths that is visible to human eyes, but we cannot see if the wavelength of the wave is shorter than this given range or if it is longer than this given range. We cannot see that wave. So in this case, this wavelength is greater than this given wavelength, means the given wavelength is greater than the visible part of electromagnetic spectrum, so we cannot see this wave. So this option is correct. They can all travel at different speeds in free space. This one is wrong. All electromagnetic waves, they have the same speed in vacuum, or we can say in free space. So different, this means this one is incorrect. So option B is incorrect. If this was same, then this option is correct. They cannot be polarized. All electromagnetic waves, they can be polarized. So EM waves can be polarized. So this is also incorrect. They consist of vibrating atoms? No. They consist of oscillating electric and magnetic fields. But vibrating atoms, they can produce EM waves. So we can say vibrating atoms can produce EM waves. But EM waves do not consist of vibrating atoms. They consist of, we can say, EM waves, they consist of oscillating electric and magnetic field. So you need to understand the difference. Oscillating E field means electric field and B field, magnetic field. So they consist of oscillating electric and magnetic field, but EM waves we can produce by oscillating charged atoms. We can produce charged atoms. So this option is also incorrect. So the answer for this question is A. Welcome to A-Level and AP Physics. In today's lesson, we will discuss some important past paper questions on waves from June 2022, paper 1, variant 1. In this lesson, we will discuss these questions in detail so you can have better understanding of these questions, and also you can improve your conceptual understanding of this topic. And in order to get maximum benefit from this lesson, please pause the video, do questions first of all by yourself, and then check solution. And this is the best way to get maximum benefit from videos. Let's study together, let's improve together. For question number 26, it is given to us a stationary wave is set up on a string that is stretched between two fixed points that are 48 centimeters apart. At one instant, the appearance of the string is as shown in this figure, and we need to find out what is wavelength of the stationary wave. So first of all, you need to understand the distance between these two fixed points. This is given to us, and this distance, this is equal to 48 centimeters. So simply we can write down this L is equal to 48 8 centimeters. We need to find out wavelength of the stationary wave. So at this point we will have node, another node we will have at this point, and this one is over antinode. So this is antinode, and this point is node, and this point is also node, and this one is antinode. And also we have node at this point, and we will have node at this fixed point as well. So in order to answer this question, we can sketch stationary wave. So this is how stationary wave will look like. Not very good looking, but you can get at least idea of this one. So this is how stationary wave will look like. Now in this case, you need to understand the distance between two consecutive nodes are antinodes. This distance is equal to lambda by 2, and this distance between next two nodes is also lambda by 2, and this distance is also lambda by 2. So we can write down lambda by 2. So in this case, simply we can write down 3 lambda by 2. This is equal to L. We need to find out lambda in this case. So simply we can write down lambda will be equal to 2L divided by 3 in this case. So we have to multiply with 48 and divided by 3. So we will get, in this case, this is 16, and 16 times 2, this is equal to 32 centimeters. So the wavelength of stationary wave is 32 centimeters, and this is how you can approach this problem. For question number 27, it is given to us a pipe closed at one end has a loudspeaker at the open end. For some frequencies of sound from the loudspeaker, a stationary sound wave is formed in the air within the pipe with an antinode at the open end of the pipe. The length of the pipe is given, that is equal to 0.85 meters. The speed of the sound in air is given, that is equal to 340 meters per second. Which frequency of sound from the loudspeaker would not produce a stationary wave? So we need to find out that frequency of loudspeaker that cannot produce stationary wave in the pipe. In order to answer this question, first thing we need to understand, it is given to us antinode at the open end, means at this point there is always antinode. In this case, we will observe antinode at the open end always, and we will observe node at the closed end. If we sketch the stationary wave inside this pipe, this is how stationary wave will look like, somewhat like this. So this is stationary wave inside this pipe, and we can also assume in this case this is equal to L, and we can assume speed of the wave inside pipe is equal to V. So L in this case is equal to lambda by 4. So we can write on here lambda by 4, this is equal to L. From here we can say lambda, this is equal to 4L. And now we can find out fundamental frequency, means the frequency of the loudspeaker we need to produce this stationary wave. That frequency is the fundamental frequency, and fundamental frequency in this case will be equal to V divided by lambda. So we can say this is V divided by 4L. So this is frequency of first harmonic, or simply we can say this is the frequency of loudspeaker we need to produce this stationary wave inside this pipe. So we can say this is F1. Now let's try to understand next stationary wave inside this pipe. So we can draw the pipe, and we can draw next stationary wave possible in this pipe. Next harmonic will have two nodes. So this is one node, and here will be another node. At open end always we will have one antinode. So if we draw, this is how stationary wave will look like. So this is just to give you idea how stationary wave will look like. So in this case we can see the distance between node and antinode, means this distance, this is equal to lambda by 4, and distance between node and antinode, this is also equal to lambda by 4, and this distance between node and antinode, this is also equal to lambda by 4. So in this case we have 3 lambda by 4, this is equal to L. So from here we can say lambda is equal to 4L by 3. So we can write down second possible frequency F2. F2 will be equal to V divided by lambda. So we can say this is V divided by 4L divided by 3. So it means this is 3 times V divided by 4L. Or we can say in this case F2 is equal to 3 times of F1 because this is equal to F1. So you can write down 3F1. Now if we sketch the next possible harmonic, mean the next stationary wave inside this pipe, then we can see the pattern, what's going on. So this is our pipe now. So this is the pipe. So let me draw a bit longer. So this is the pipe. Here we have 2 nodes. Now we will have 3 nodes. 1 node here, 1 node here. So we will have 3 nodes now. We can draw the stationary wave formed inside this pipe. So this is how stationary wave will look like. Just to give you idea how stationary wave will look like inside this pipe. So this is how stationary wave will look like inside pipe. I mean this is our next harmonic. In this case we can also write down in terms of lambda by 4. So this is first lambda by 4 and here we will have an other lambda by 4. So this is lambda by 4 and here we will have lambda by 4 and here we will also have lambda by 4. So in this case you can see we have 5 lambda by 4. 5 lambda by 4, this is equal to L. So we can say from here lambda, this is equal to 4L by 5. So we can write down the frequency. So frequency in this case will be equal to 5V by 4L. 5V by 4L. So we can say the third frequency means the third frequency of loudspeaker we need to produce this stationary wave. That one has to be equal to 5 times of fundamental frequency. From here you can see if we compare here F1 and here we have this is F2 and this one is F3. So we only see odd harmonics. So it simply means that for one end closed pipe, for one end we can say closed pipe, only odd harmonics are produced. Only odd harmonics are produced. If pipe is open at both ends, we will observe odd and even harmonics, but if closed at one end, we will only observe odd harmonics. So this is the main point you need to understand. Only odd harmonics. So this is very important. If one end closed pipe, we will only observe odd harmonics. Now in this case we need to calculate first of all fundamental frequency. In order to calculate fundamental frequency, we can write on here F1. F1 is equal to V divided by 4L. So V is equal to 340 divided by 4 times L. L is equal to 0.85. So our answer in this case will be equal to 100 Hertz. So this is the first frequency of loudspeaker we need. And the second frequency of loudspeaker we need has to be 3 times of this one. It means this one is possible, this one is possible, and the next one will be 5 times of F1. This is also possible. But this frequency of loudspeaker cannot produce stationary wave inside the pipe. So this is the right answer. So the answer for this question is B. You need to understand for this question, if one end is closed, only odd harmonics are produced. Or simply you can remember Fn, this has to be equal to n times F1 if one end closed pipe. And n can be 1, it can be 3, it can be 5, it can be 7, it can be 9, it can be 11, and so on. Only odd numbers. N can be only odd number. So you can also remember simply this one, and next time you can find answer very quickly by yourself. So this is how you need to approach this kind of problems. For question number 28, it is given to us water waves of wavelength lambda are incident normally on an obstacle with a narrow gap. The width of the gap is equal to lambda. The waves from the gap emerge over an angle theta as shown in the figure. The gap is slowly widened. which changes, if any, occur to the theta and to the wavelength of the emerging waves. So first of all, let's try to understand what is given to us. In this case, it is given to us the wavelength of the waves is equal to lambda. The wavelength is equal to lambda. And gap size is also given, gap size that is also equal to lambda. So it means that in this case there will be significant diffraction. So we can write down there will be significant diffraction. There will be significant diffraction. Now we also need to understand what will happen to the lambda if we widen this gap, means if we increase the gap size. What will happen to lambda? Let's try to understand what is the relationship between lambda and speed of a wave. Speed of a wave, it depends on medium. Speed of a wave, it depends on medium, and speed of wave also depends on type of wave. Type of wave means different waves, they have different speed in same medium. For example, speed of light and speed of sound in air is different. So different waves, they have different speeds in same medium. For this question, it is given to us, we have water, this is our medium, this is before this obstacle, and after this obstacle we also have water. So water is the medium. So in this case, medium is not changing. So if medium is not changing and type of wave is also the same, it means that speed of the wave will not change. If speed of the wave is not changing and frequency of the wave is the same, so it simply means that lambda also stays same. So this is what we need to understand about wavelength. Now let's try to understand what is effect on theta when we widen this gap. For theta, we need to understand this is linked with diffraction. So theta is linked with amount of diffraction. So we can say this is linked with amount of diffraction. And amount of diffraction, this is depending on gap size, and it depends on wavelength, how they change. If gap size increase but lambda stays same, as in this case lambda is not changing, so it simply means that there will be less diffraction. So we can write down, if gap is increasing and wavelength, same type of waves are coming, so there will be less diffraction. Less diffraction simply means that theta will decrease, and vice versa is also true. So we can also write on here gap size, how this is linked with lambda. If we decrease gap size and same type of waves are coming in the same medium, means lambda is the same, so in this case there will be more diffraction. In this case there will be more diffraction. Simply we can say theta will increase. But in this case gap size is increasing, so it means theta will decrease and lambda will stay same, because type of wave and medium is the same. So the answer for this question is A. So this is how you can approach this problem. Let me explain to you this one using different figures, how gap size will affect diffraction. So let's try to understand with the help of figures. In this case, you can see, if you look at this figure, this is the gap size, and if you look at the next one, we have increased the gap size, that we are keeping lambda same. So you can see how angle is changing. In this case you see this angle is decreasing, means there is less diffraction, and in this case is very little diffraction. So diffraction is decreasing if we widen the gap. If we increase gap size, diffraction is decreasing. So the answer for this question is A. So very important point you need to understand, how gap size and lambda, they affect amount of diffraction. So in this case waves, they spread out more, here they spread out less, and here they spread out very little. So they just almost, they go straight through this one, so there is very less diffraction. For question number 29, it is given to us light of single frequency passes through two narrow slits and produces an interference pattern on a screen some distance away. The interference fringes are very close together. Which change would increase the distance between the fringes? So the first thing for this question we need to understand is this is Young's double slit experiment, because it is given to you in this question. There are two narrow slits. So we can sketch first of all. So imagine that we have these two narrow slits and we place one screen at certain distance from the slits. And let's say the distance between screen and the slits, this distance is equal to capital D. And the distance from center to center of these two slits, let's say this distance is equal to A. And A we call, this is slit separation. So we can simply write down A is slit separation. In this case, we will observe one center maxima. We will also observe first order maxima, second order, and so on. On this side also we will observe first order, second order, and so on. So this is first order, mean n is equal to 0. And we need to understand the distance between any two consecutive bright fringes are maxima is equal to x, and this is called fringe spacing. So x is fringe spacing. Let's try to answer this question using Young's double slit equation. According to Young's double slit equation, Ax is equal to lambda times capital D. So we can rearrange and we can write down x is equal to lambda capital D divided by A. If we want to increase x, increase the distance between the fringes, mean increase x. In order to increase x, we have one option. We can decrease A, mean we can decrease slit separation, so x will increase, or we can increase D, so x will also increase. Now let's try to find out the best possible answer. For option A, it is given to us increase the brightness of the light source. Brightness does not affect fringe spacing, so A is not correct answer. For option B, it is given to us increase the distance between the slits and the screen, mean increase this capital D. So if we increase capital D, x will increase. So this can be the answer, mean this is correct answer. If we go to C, increase the distance between the slits, this is telling us increase A. So if we will increase this one, x will decrease, so this is incorrect. So this one is incorrect. Increase the frequency of the light used. If we increase the frequency, it means that lambda will decrease. So if lambda decrease, it means x will decrease. So this is also incorrect answer. So the answer for this question is B. B is correct answer. For question number 30, it is given to us light of wavelength 5.4 times 10 to minus 7 meters is incident normally on a diffraction grating. The separation between adjacent lines in the grating is 2.0 times 10 to minus 6 meters. The light that emerges from the grating falls on a semicircular screen as shown in the view from above. The grating is at the center of the semicircle and the lines of the grating are vertical. How many bright dots are formed on the screen? Bright dots simply means that maxima, or simply you can say bright fringes. So for this question we need to find out total number of maxima on the screen. This question is about diffraction grating and this is typical type of question. So you need to understand d sine theta is equal to n times lambda. In this case, we need to find out number of bright dots or maxima. So we can say n is equal to d sine of theta divided by lambda. We need to find out maximum number of bright fringes and max. So theta in this case has to be equal to 90 degrees. So we can say this is d sine of 90 degrees divided by lambda. But sine of 90 degrees we need to understand is equal to 1. Sine of 90 degrees is equal to 1. And so simply we can write down in this case n max is equal to d divided by lambda. Value of d is given to us. So this is value of d. d in this case is equal to 2.0 times 10 to minus 6 meters, and value of lambda is given, that is 5.4 times 10 to minus 7. So simply we need to divide by this 5.4 times 10 to minus 7, and in this case our answer will be about 3.7. But now we need to understand maxima are bright fringes, they cannot be 3.7, so they cannot be 1.5, so that is not possible. So in this case n max means the number of bright fringes, they will be equal to 3. So this is number of bright fringes, they cannot be 3.7, so this has to be integer. So this has to be integer, it cannot be 3.7. there are no 1.5 bright fringes. So in this case we will observe 3 bright fringes on one side of the center. So we will observe 3 bright fringes here, there will be 3 bright fringes on one side. We will also observe and other 3 bright fringes on the other side. So we will have total 6, and there will be 1 bright fringe at the center. We can simply write down n total will be equal to 2 times of n max plus 1. So total number of bright fringes will be equal to 7 in this case. So the answer is D. A typical type of question, how to find total number of bright fringes or total number of maxima. In this case they are saying bright dots, so they are the same thing. So typical type of question, you need to understand how to approach this. I hope this question is clear to you, and also I hope you have better understanding about waves. If you have any questions, please just leave your question in comments and I will be answering as soon as possible. Bye for now. Welcome to A-Level and AP Physics. In today's lesson, we will discuss some important past paper questions on electricity from May-June 2022, Paper 1, Variant 1. In this lesson, we will discuss these questions in detail so you can improve your conceptual understanding of this topic. Let's study together, let's improve together. For question number 31, it is given to us a straight copper wire of diameter 0.42 times 10 to minus 3 meters has a number density of free electrons of 8.5 times 10 to 28 per cubic meter. In a given time interval, a charge of 0.15 coulombs moves through the wire. What is the average displacement of the free electrons along the wire in this time interval? This question is simply about transport equation. Transport equation is simply I is equal to NQ VA. We need to calculate in this case average displacement. In order to calculate average displacement, we can replace I with Q over T and we can write down Q over T is equal to NQVA. Q is the total charge and this Q is the charge on single electron. So you cannot cancel this Q with this Q. These are two different Qs. From here we can write down capital Q. This is equal to NQA V times T, but velocity times time, this is equal to displacement. So we can write down Q is equal to NQ A times displacement. So S is the displacement and we need to calculate displacement. So we can say S is equal to capital Q divided by NQ times A. Q is the total charge, that is equal to 0.15 coulombs. N is the number density, that is equal to 8.5 times 10 to 28 per cubic meters, means number of free electrons per cubic meter. And Q is the charge on single electron, or we can say this is the charge on single charge carrier, 1.6 times 10 to minus 19 coulombs. Times cross-sectional area, diameter is given to us, so we can say this is pi by 4 d square. So we can multiply with 0.42 times 10 to minus 3 square of this. And now if we solve this one for s, our final answer will be equal to 8.0 times 10 to minus 5 meters. So this is the answer. So this is what you need to calculate, and this is the average displacement of free electrons in given time interval. So our answer for this question is C. For question number 32, we need to find out what is definition of the potential difference across a component. Potential difference simply is equal to work done per unit charge. Work done per unit charge. Or simply we can say this is the energy transfer to the component per unit charge. Per unit charge. So this is how we can define potential difference. It simply means that when unit charge passes through a component, how much energy is transferred to the component. If we talk about resistor, in case of resistor, when unit charge passes through resistor, how much electrical energy is converted into thermal energy. That is potential difference. Let's try to find out what is the best possible option. If you look at option A, it is given to us electrical power supplied to the component. This is incorrect option. But if you look at option B, it is given to us this is energy transferred to the component per unit charge. So this is our answer. So this option is correct. For option C, it is given to us the product of current in the component and its resistance. This is not definition of potential difference. For D, it is given to us voltage across the component. This is not how we define potential difference. So this is also incorrect definition of potential difference. So the answer for this question is B. We need to understand how we define potential difference. So this is how potential difference is defined. For this question, it is given to us the graph shows the IV characteristic for a semiconductor diode. Which statement can be deduced from the graph? This question is simply about understanding of this graph. If we have clear understanding of this graph, we can answer this question very quickly. Let's try to understand a little bit about this graph first of all. If you look at right side, we can see with the same increase in potential difference, increase in I is getting bigger and bigger. So simply we can say in this case resistance is decreasing because resistance is the ratio between potential difference and current passing through resistor. In this case we have diode. So for the same increase in potential difference, if the increase in I is getting bigger and bigger, it simply means that resistance of the component is decreasing. So this side resistance is decreasing with increase in potential difference. But on left side, the resistance is very high because increase in current is very little, almost there is no increase in current. So we can say resistance is very high on the left side. Actually this is called forward biased. So this is forward biased and this one is reverse biased. This one is reverse biased. Now we have some understanding of this graph. Let's look at given options and try to find out the best possible option. If you look at option A, it is given to us above a certain positive potential difference, diode obeys Ohm's law. This is incorrect. If this diode obey Ohm's law, then V and I, they have to be directly proportional. So this one is incorrect. Option B, current is directly proportional to potential difference. This is also statement of Ohm's law. This is also incorrect. If you look at option C, it is given to us diode has zero resistance when current in the diode is in one direction. Resistance will be zero when current is infinite. Means when current is infinite, resistance will be zero. But current is not infinite. So option C is also incorrect. For option D, it is given to us the resistance of the diode depends upon potential difference across it. and this one is true. As potential difference is increasing, resistance of diode is decreasing. So it simply means that resistance of diode is depending on potential difference across diode. So our answer for this question is D. So very important point about diode, you need to understand resistance of diode depends upon potential difference across diode. So our answer for this one is D. For question number 34, it is given to us a wire has a resistance of 30 ohms. A second wire is made from the same material, has the same mass, and is 3 times as long as the first wire. What is resistance of the second wire? So in this case, we can imagine that, let's say we have one wire, this is wire A, and the second is wire B. For wire A, it is given to us the resistance of wire A, we can simply say this is RA, and the value of its resistance is given. So we can also say resistance of wire B, let's say this is RB. They are made of the same material, means the resistivity of these two wires is the same. Resistivity is the same, have the same mass. If they have the same mass and density is also the same, so it means that volume also is the same. For the first wire, it is given to us as the same mass and is 3 times longer. For the first wire, let's say the length of first wire is L. So the length of second wire, this one will be 3L. Now let's say the cross-sectional area of wire A is capital A. So what is cross-sectional area of second wire? But in this case, mass is the same, density is the same. It means the volume of wire A has to be equal to volume of wire B. Volume of wire A, we can simply write down, this is A times L. And the length of the second wire is 3L. So the cross-sectional area of this wire has to be equal to A by 3. So we can write down this is A by 3. Now in this case, we need to find out resistance of second wire, means resistance of RB. We can write down resistance of RA. Resistance of RA will be equal to rho L by A. So the resistance of RB, we can say this is rho. L is equal to 3L and cross-sectional area is A by 3. If we simplify this, we can say this is rho L divided by A, and we have here 3 multiply by 3. So in this case, we will get, here we will get RA, because this is equal to resistance of wire A times 9. So this is RB. So simply we can write down here now, resistance of wire B is equal to 9 times of resistance of wire A. 9 times resistance of wire A. Resistance of wire A is given. So if we simply multiply, our final answer will be equal to 270 ohms. So this is resistance of wire B. So this is how you can approach this type of problem. You need to understand the technique, the method we use. So the answer for this question is D. For question number 35, it is given to us a cell has internal resistance small r and electromotive force capital E. The cell is connected in series with an ammeter and a variable resistor of resistance capital R. When R is equal to 10 ohms, the ammeter reads 0.3 amps. When R is equal to 5 ohms, ammeter reads 0.4 amps. What is value of E? So for this question, we need to find out value of E. In order to find value of E, we can consider first of all when I is equal to 0.3 amps. So we can write down E is equal to I current in the circuit plus load resistance plus internal resistance. We need to find out value of E. I is given, that is equal to 0.3, and value of R is given, that is 10, and value of small r is not given. We can also rewrite this equation when current is equal to 0.4 amps. So we can rewrite E is equal to I current in the circuit times load resistance times internal resistance. In this case, current is equal to 0.4 amps as it is given here. Load resistance is equal to 5 ohms and internal resistance is not given. We can say this is equation 1. and this is second equation. In this case, these two equations are equal because E is equal to this and also E is equal to this one. So simply in this case, we can equate 1 and 2. So we can say 1 is equal to 2 by equating equation 1 and 2. Equation 1, 0.3 times 10 plus small r, this one is equal to 0.4 times 5 plus r. If we multiply this one inside, we will get 3 here, plus we will get, this is 0.3 times r. And if we multiply this one inside, in this case we will get 2 plus 0.4 r. From here we can get value of r. So r will be equal to, in this case r will be equal to 3 minus 2 divided by 0.1. So simply we will get r is equal to 10 ohms. So this is value of internal resistance. R is equal to 10 ohms. Now we have value of r, we can use any equation and we can find out value of E. Let's try to find out value of E using equation 2. According to equation 2, E is equal to 0.4 times 5 plus R, but R in this case is equal to 10. So we can write down 0.4 times 5 plus 10. Now we can simplify. This is 0.4 times we have 5 plus 10, so this is equal to 15. If we multiply this inside, we will get value of E. This is equal to 6 volts. So the value of E is equal to 6 volts. And our answer for this question is D. So this is how you can approach this type of problems. This is also kind of typical question. You need to understand how to find internal resistance and how to find EMF of battery. Very nice question. You need to get very clear about this type of problems. And this is how you can answer this type of questions. Welcome to A-Level and AP Physics. In today's lesson, we will discuss some important past paper questions on electricity and radioactivity from May-June 2022, Paper 1, Variant 1. In this lesson, we will discuss some typical type of questions about electricity and radioactivity. And we will discuss these questions in detail so you can have better understanding of these questions and also you can improve your conceptual understanding of these two topics. Let's study together, let's improve together. For question number 36, it is given to us the sum of currents entering a junction in an electrical circuit is always equal to the sum of the currents leaving the junction. Why is this? So we need to justify this one. Let's try to understand what is happening at any junction in a circuit. At any junction in a circuit, the amount of charge entering the junction has to be equal to amount of charge leaving the junction. Or simply we can say number of electrons entering a junction has to be equal to number of electrons leaving the junction. Simply we can write down this one, sum of charge entering a junction has to be equal to sum of charge leaving the junction. So we can say Q out. They have to be equal. But if we divide this one by T, if we divide charge entering a junction by T, and if we also divide charge leaving a junction by T, so we can say this is divided by T. So Q over T, this is equal to current. So we can say this is I in, means sum of currents, means total current entering. This one will be equal to total current leaving. Total I leaving means sum of currents leaving a junction. So that's reason current entering a junction has to be equal to current leaving a junction, because this is based on conservation of charge. So this is based on conservation of charge. So this is simply conservation of charge. Conservation of charge. Current entering the junction has to be equal to current leaving the junction. It is based on conservation of charge. So the answer for this question is A. It is consequence of the conservation of charge. So our answer for this question is A. For question number 37, it is given to us, in the circuits shown the temperature remains constant. In which circuit does the potential difference V increase with increasing light intensity? With increasing light intensity. So we can write down here first of all light intensity. Light intensity. So when light intensity increase, potential difference increases. We need to find out that circuit. So in this case, we need to understand this component is thermistor. So we can also write down the names of the component. Thermistor. And this one is LDR, light dependent resistor. And this one is common fixed resistor. This is also LDR. And this one is thermistor. This is LDR. This one is thermistor. Now we need to understand, if you look at circuit 1, in this case temperature remains constant. If temperature remains constant, it means the resistance of this thermistor will remain constant. So this resistance remain constant. So it means that if light intensity increase, there will be no change in this potential difference, because resistance of this one is constant and resistance of this one is also constant. So there will be no change on this voltmeter reading. Now if you look at option B, in this case, when light intensity will increase, resistance of LDR decreases. Resistance of LDR decreases when light intensity increases. So we can simply sketch, let's say we have resistance, this is for LDR, and here we have light intensity. So you can understand better what is the shape of the graph. So in this case, if we sketch a graph between resistance and light intensity for LDR, you will see the shape of the graph is like this. So as the light intensity is increasing, resistance of LDR is decreasing. So if resistance of LDR decrease, so this potential difference also will decrease. So this is also not possible answer. Now if we go to option C, in this case you can see same situation, resistance will decrease if light intensity increase. So resistance of this one will decrease if light intensity increase. So if light intensity increase, resistance will decrease, so the voltmeter reading will decrease. So this is also not possible answer. Now if we go to option D, in this case we need to understand, as light intensity will increase, resistance of this one will decrease. Resistance of this one will decrease. So potential difference, or we can say if we connect a voltmeter across this one, the reading of voltmeter will decrease. But in this case, EMF of the battery is fixed. So we can say the VT means this is potential difference across thermistor, plus we can say the potential difference across LDR. So when light intensity will increase, the potential difference across LDR will decrease. But EMF of battery is constant, so the potential difference across thermistor in this case will increase because temperature is constant. So this reading will increase. So our answer for this question is D. So this is how you can approach this problem. For question number 38, it is given to us carbon 14 decays into nitrogen 14 by emitting a beta minus particle. Which statement explains why the beta minus particles are emitted with a range of kinetic energies? First of all, we can write down this nuclear reaction. So in this case, we have carbon 14. So carbon has atomic number 6. And its mass number is 14. It decays into nitrogen 14, means mass number of nitrogen is 14 and atomic number of nitrogen is 7. And in this case, beta minus particle is emitted, and also there will be electron neutrino, anti-neutrino, electron anti-neutrino, because this is electron. This particle, beta minus particle, this one is electron, so this has to be anti-neutrino. This is simply, this one is electron, and this is electron anti-neutrino. So in this case, energy released in this reaction, this energy will be shared between these three particles. So some of the energy will be taken by this. The least amount of energy will be taken by nitrogen, because this is very heavy nucleus, so its speed will be very slow, and rest of the energy will be taken by these two particles. But when we look at kinetic energy of beta minus particle electron, we observe always in the same reaction kinetic energy of beta minus particle, or simply you can say electron, that was different. So then we thought there must be an other particle that is also released with nitrogen 14 and also beta minus particle, because before this was not discovered, neutrino was not discovered that time. So then scientists, they start thinking about this one, why energy of this particle every time is different, kinetic energy every time is different. Then there was a theory about this one, that there is an other particle, and that particle was neutrino. In this case is electron antineutrino. So this is how neutrino was discovered before it was detected. So before detection, theoretically we discovered there must be another particle, and then later this neutrino was detected as well. So neutrino was discovered before detection. So the kinetic energy is shared between, the energy released in this reaction is shared between these three particles. So we can write down, is shared between these three particles. So this is what you need to understand. Now if you look at different options, if you look at option A, carbon 14 nuclei have slightly different masses. This is not possible answer. The emitted beta particles have a range of different masses. Mass of electron is fixed, so this is also wrong. The energy released in the nuclear process is different for each carbon 14 nucleus. Total energy is the same, but energy is shared between these particles. So this is also not possible answer. So answer has to be D. The energy released in the decay process is shared between the nitrogen 14 nucleus, this nucleus, beta minus particle, and antineutrino, electron antineutrino. So the answer for this question is D. Very historical event in physics, how neutrino was discovered before it was detected. So you need to understand this is due to beta decay. I hope it is clear to you, and very important question. For question number 39, it is given to us a nucleus of a radioactive element emits an alpha particle, then a beta minus particle, then another beta minus particle. Which statement describes the final element that is produced? Imagine that we have nucleus X, and this nucleus X decays into nucleus Y by emitting one alpha particle and by emitting two beta minus particles. So in this case we can also assume atomic number of X is C and the mass number of X is A. Now we need to find out what is mass number of Y and what is atomic number of Y. In this case we can simply understand that A is equal to something here, and this is the mass number of Y, plus we have 4 and plus we have 0, because mass number of beta minus particle is 0. So this one has to be A minus 4. So simply we can say mass number of Y, this is A minus 4. Now we can also find out atomic number of Y. Atomic number of Y, simply you can see this decreases by 2, and here we have minus 2. So due to this one alpha particle, atomic number of Y will decrease by 2, but due to beta minus particle, atomic number will increase by 2. So it simply means that atomic number of Y is the same as atomic number of X. As atomic number is the same, it means element is the same. So it means X and Y nucleus, they belong to same element. Atomic number is same, it means same element. atomic number is also equal to proton number. So as proton number is not changing, it means these two nuclei, they belong to same element. They belong to same element. As they have different neutron number, or we can say mass number is different, so they are isotope of same element. So they are isotope. So if you look at option C, it is given to us, it is an isotope of the original element. So the answer for this question is C. Rest of the options are not possible, so the answer is C. For question number 40, we need to find out how many hadrons, baryons and mesons are there in this given nucleus. First of all, let's try to understand what are hadrons, what are mesons and what are baryons. Hadrons we can classify into baryons, and we can classify into mesons. Baryons, they consist of 3 quarks. Means the particles, if it consists of 3 quarks, that particle is baryon. And if particle consists of 1 quark and 1 antiquark, that particle belongs to mesons. Now if you look at this nucleus, for this nucleus we have mass number of this nucleus is equal to 9. It simply means that this is equal to sum of protons plus neutrons. So simply we can write down protons and neutrons. And this nucleus, it consists of 4 protons and it consists of 5 neutrons. Now we need to understand proton, it consists of 1 down quark and it consists of 2 up quarks. So this is composition of proton. And neutron consists of 1 up quark and it consists of 2 down quarks. So it means proton and neutron, they consist of 3 quarks. So it means proton is a baryon, and neutron is also baryon. Baryons, they belongs to hadrons. So this is subclass of hadron. So we can also say proton and neutron, they are also hadrons because they belongs to hadron family. So neutron is also hadron. So this is also hadron. So in this case we have 9 hadrons. We can simply write down. So we have hadrons 9 and we have baryons also 9, but we have number of mesons equal to 0. No meson because they do not consist of quark and antiquark. So the answer for this question has to be C. We have 9 hadrons, 9 baryons, but no meson because they consist of 3 quarks, not 2 quarks. So the answer for this question is C.